Hey guys, thank you so much for joining in on this live session with Manifold AI Learning. So folks, can you please confirm whether you can hear my voice and see my screen? So please let me know if you're able to hear my voice and see my screen. Okay, thank you Rakesh. Thank you Dheeraj. Thank you Blessy. Thank you, Suraj. Okay, thank you guys for your confirmation. And thanks again, everyone, for those of you who joined for this live session on large language models. So the key topic of today's discussion is what are these large language models, why is it so important, and we'll also look into the application and it's how it is actually trained. So we'll learn everything at a very high level so that you understand what are these large language models and the importance of these large language models. Now, before we get started with today's agenda, guys, so this session has been made possible with the team of Manifold AI Learning. So, Manifold AI Learning is a e-learning company who's into providing the training on some of the hot skills in the current market, which includes the machine learning operation, generative AI, LLM ops, the natural language processing, AWS certification. So I've got an opportunity to create multiple courses with Manifold AI Learning, and one of the recent course which is in high demand right now, which it's called as NVIDIA Certified Associate course. So if you're someone who's planning to take your NVIDIA certification, I highly recommend you to check out this course from Manifold AI Learning. So this course is still in progress. So we have been able to add two topics, which is about the introduction of machine learning and deep learning. The next module of large language models is in progress. You can expect the update of this large language models and the prompt engineering in the coming weeks. So the idea is to have the most of the content ready within June 15th. So go ahead and check out the course. I've already shared you the link in the chat window. So this is an introductory price, and this is available only on our site, that is Manifold AI Learning. You can also check out the other courses as well. There's another one that's called as the Mastering the Generative AI in 2024. This is basically a package which includes all the courses which are relevant to generative AI from the team of Manifold AI Learning. It includes the 14 plus courses and any new course that gets created in this generative AI space. You get the access to that course for free. It's like a one-time investment for your professional development. So go ahead and check out the same. Okay. And I see a question from Blissy. Why NVIDIA and why not advanced GPUs with SageMaker? I would like to know. Okay, so that's a good question, Blissy. So the reason the NVIDIA is because this is in alignment with the certification that is being offered by NVIDIA. So NVIDIA is currently offering a certificate on generative AI LLMs. The examination code is NCA Gen L. So the course that I had previously described, it's basically has been created for to prepare for the learners in alignment with the certificate examination preparation. So you can actually check out that course page for more details. I've also added, there's also a video that is added in that course page, which helps you understand what exactly is this course. And there is also information provided as how to get started with this with this certification, actually the key things to focus on. So everything is explained over there. So the course that is NVIDIA certification, it's specifically in alignment for the certificate examination from NVIDIA. So this is one of the recent certification that NVIDIA started giving, conducting the examination. So the course is there primarily to help the learners, but to add more information, like for it, that course is also helpful for the people who's also interested to learn more about the generative AI. So that's the overall idea, Blissy. Okay, generative course was excellent. I just completed. Wow, that's amazing, Blessy. So, uh, uh, I'm, like, we are glad to know that you like that course from us, and please do share us the feedback for any improvement. So we'll be happy to include those feedback to ensure that uh, we want to provide the same learning experience on all our courses from Manifold AI Learning. Okay, thank you again, Blissy. Perfect. Thank you, Blissy. Okay, thank you so much, guys. And so let's come back. Uh, okay, so as I mentioned, you can also check out this generative AI package. So if you're someone who is interested in the like making a one-time investment and have the access for all the future releases from Manifold AI Learning in the generative AI space. Okay, now let's come back to our today's agenda, which is about the exploring the power of large language models. What exactly is this large language models, the importance of it, and we'll also look into the high level details as how these large language models are basically trained. So let's start with large language models. So what are these large language models? Now, when we say large language models, so think of it as a kind of a model which has been trained on enormous amount of text data. Suppose I'm going to say this as a large language model. Let's consider an example. So think of this LLMs or the large language models are basically the models which has been trained on enormous amount of data set. Okay, so like when I say enormous amount, literally it uses the text data from various sources. So it could be from books, it could be from websites, it could be from code repositories and many more. So all these data will act as a learning material for this large language models. Now, as they process this large volume of data, these LLMs, what it starts to do is it starts to identify the pattern in how these words and phrases are actually used. So it will refer to this large volume of text and then it will try to understand the relationship between those words. And not only that, even it will learn the nuances of the language as well because you will be training it with the large volume of the data set. When that is actually happening, okay, when that is actually happening, once this pattern has been identified, so this pattern recognition will allow these large language models to predict the most likely next word in a given sentence given the preceding words. So that's the main foundation of their ability to generate the text. So basically what happens is during the training in a general sense, we'll be training this large language model on a language modeling task. Now, what is large language model or a language modeling task? So it's basically we are going to like feed in the large volume of text, and the idea is given the current word, I want to predict the next word. So that's the overall idea. That task is called as the language modeling task from the natural language processing, and on based on this task, so we have trained this large language model. Now, once we have learned all this pattern, we are able to generate that text. That means given a sequence of text that I've got, I want to predict what is the next word. So that's the core idea of this large language model. And when we talk about working such like working with such large language model, so when we are working with the natural language data, these large language models, they don't just consider the individual words, but most importantly, they understand the context in which those words are actually used. Now, by doing this, this would allow them to grasp the meaning of a sentence, even if it contains the ambiguous words or phrases. And when we are working with large language models, so what it represents is, so it represents the uh, words, phrases, so all those things that we have got, especially in the form of a vector representation that's called as the embeddings. So these embeddings, so it actually capture the overall semantic meaning of the words and their relationship with the other words. So here, like if I want to now describe this large language models in general, so that you can quickly make a connection about it. So think of these large language models as a class of deep learning architecture that's called as the transformer network. So if you have attended our previous session on transformer architecture, so you might have understood that the transformer architecture is basically made up of encoder decoder architecture. We'll have the series of encoders and the decoders, but it has got some key components that would enable us to learn the relationship between the words in an effective manner. Now, these large language models or these LLMs, they generally and they largely represent a class of such transformer architectures or the transformer networks. Okay, now this transformer model is basically a neural network that learns the context and the meaning by overall tracking the relationship in a sequential data, especially the words in a given sentence. Now, when we are working with this transformer architecture, like as you have learned in our previous session as well, so it's made up of multiple transformer blocks, which we also call it as the layers. Like if I want to bring up that transformer architecture, let me just bring up the same. So this is how a transformer architecture would look like. Now, this transformer architecture, as you can clearly see, it's made up of multiple layers. And we have something called as a self-attention layer that you would see right here. We have got self-attention layer, and we have got the feed-forward neural network layer here. We have a masked attention here. Okay, we have got some kind of normalization layers right here. So these layers are working together that would enable us to understand what is being provided as an input so that we can generate the output which is in line with our expectation. Now, these layers are actually stacked to make a deeper transformers and the powerful language models. And this overall architecture was actually introduced in a research paper by Google. It was called as Attention is All You Need in the year of 2017. So that's the idea of this transformer architecture. Now, there are two key innovations that actually make these transformers one of the best thing for the large language models. They are basically the positional encoding and the self attention. So these are the two key innovation that actually made a key impact for our large language models. Now, when we talk about the positional encoding in our transformer architecture, what it does is it's going to embed the order in which the input occurs within a given sequence. So, if you remember, before the transformer architecture, what we were actually using is we were making use of the RNN or the LSTM in order to work with the sequential data, which means when I had a stream of words and if I want to process the stream of words, so in such scenarios, I was making use of the RNN or LSTM, and I was I was just processing one word after the another word. So that's a basic structure that we were following in the case of this RNN and LSTM. Now with transformer architecture, we mentioned that we are going to send all the words together. Suppose if I've got 5 words, we have mentioned that we are going to send all these 5 words in parallel. Now, when I'm sending all these 5 words in parallel, then in such scenarios, our natural language has an importance towards the order in which the words are being used. To give you an example, suppose if I have the sentence that says as dog eats man and man eats dog. So even though there's a difference in the order between dog and the man position, the meaning is entirely different. So the order plays a important role when we are dealing with the text data. And that is where the innovation of positional encoding comes into picture. So with this positional encoding, so what it has helped us is it has helped us to embed the order in which the inputs are occurring in a given sequence. Even though I'm sending the data in the parallel, so with the help of this positional encoding, we are able to inject that information. So this is like saying that instead of feeding the words in a sequential manner into the neural network, so we are able to send it in a non-sequential fashion, in this case in a parallel manner, because we are already injecting the position with the help of this positional encoding. So that's the key idea of this positional encoding. And we have another important innovation, especially in this transformer architecture, that's called as the self-attention mechanism. Now, what this self-attention mechanism does is it is going to assign a weight to each part of the input data while processing the given information. Okay, so what it says is, okay, I'll give you an example. Suppose if I've got a sequence that says as the dog is crossing the road, it is very tired. Now, if I ask you, what is this word it is actually referring to? As a human, it's easier for us to say that, okay, this word it is actually referring to the word of dog. But if I want to make my system to understand this kind of complex relationship, that's where it becomes challenging. And that's where the self attention shines. So, what it says is, whenever we are processing the current word, it will also look into the other words in my given sequence and it will assign the weightage to it. For example, if I'm processing the word of it, I'll be assigning more weightage for the word dog compared to the other words. So that is the whole idea right here. So the self-attention layer, it's going to assign a weight to each part of the input data while it is processing the current word. And this weight signifies the overall importance of that particular word in the context of rest of the input. So that means when it is processing that specific word, we are giving a direction that how it has to focus its attention. So it means the system no longer have to provide the equal importance for all the words. They'll have to provide the importance for the words that is actually mattering for the overall context of the word that we are dealing with. So as a result of this, this will tell the neural network as what are the words it has to pay attention to over the period of time. So these two techniques in I will say in conjunction, like together, they actually help us in analyzing the overall context that we have got in a given data set, and we are able to increase the speed of training because of parallel processing. With all these advantages, okay, with all these advantages, we started seeing a lot of developments in the area of this large language models. Now, historically, when we think about it, so when we think about the artificial intelligence model, it was actually focused on the like just understanding the given data, like whatever the data that we have got, we wanted to just understand what was present in my given data set. So we were basically interested in finding the pattern. Now, what has happened was, because we were able to train it on huge volumes of data set, just like I mentioned earlier at the beginning of today's session, we were able to train it on large scale data set from books, website, code repository with huge scale data set. And we were able to train the neural network, which has got billions of parameters. So this has unlocked one of the new ability in this model, that is generation of the human content. Generation of human like content. See, before the generative AI, so what we were actually dealing with was basically the machine learning model and the deep learning model, which was essentially helping us to find the pattern in the data set. But with this large language models, we were able to come up with an ability to generate the human like content. So we were able to use the models to read, write, code, create a drawing, create, let's say, like inject a creativity, create a book, improve the productivity across the industries, especially when it comes to solving the toughest problem. That's where we started seeing the ability of this artificial intelligence and these large language models. And these applications of these large language models, it spans across various use cases. So to name a few, so it's used in healthcare, like the diagnosis support. The LLMs can actually now analyze the vast medical literature as well as the patient data so that it can help the doctors to identify the potential diagnosis and the treatment options in a faster and an accurate way. And in the healthcare sector, it is used in personalized medicine as well as the patient communication. And it's used in finance. So LLMs can actually go through huge volumes of the data set that would help the business to just potentially flag the potential fraud transactions in real time. It is used in risk assessment, customer service, and so on. And these LLMs have got a greater application in creative writing as well. So LLMs can brainstorm ideas, LLMs can generate the plot outlines, even draft the entire pieces of text. This would basically provide the valuable information and valuable inspiration for the writers. And these LLMs can also analyze the text and suggest the improvements in grammar, vocabulary, as well as the overall style that would help the writers to polish their work. And collaborative storytelling, the LLMs can co create the stories with human authors, which will lead to unique and engaging narratives. And these LLMs are used in customer service. It can handle the customer inquiries around the clock without getting tired, provide quick and accurate responses, and even outside the business hours too. So these LLMs will help us with personalized interaction. The LLMs can understand the customer requirements and the preferences, and these LLMs can tailor the responses to provide a more personalized experience. And the best part is scalability. The LLMs can handle large volume of customer queries in a simultaneous fashion. So as a result of this, this will improve the efficiency and reducing the response time to the end users. And it's not just these, like the potential of these large language models, it extends far beyond these examples. They're used in education to create the personalized learning experience. In law, it is used to draft the legal documents, and in research, it is used to accelerate the scientific discovery. The possibilities are truly limitless, and all these are possible because of the data that we have been trained with. As I mentioned, we have trained such large language models on huge volumes of data set. Now, because of this ability, we are now able to get because of this we are now able to uh, get the model which performs really well on the new data as well. So that's the core idea of this large language models. Now when we talk about such large language models, so here these large language models are basically have like whatever that I've described, it's more to do with the, I would say, a sector wise. So if I want to name some of the applications of these large language models from the task that we generally talk about, so these large language models are basically used for generation. So that's what the entire generative AI is all about, which is about generation of new data using the patterns it has learned from the training data. And the another task that you would do using this large language model is the summarization, like legal document paraphrasing, meeting note summarization, and so on. Translation, which is like conversion of the text from one language to the another language. Classification, that is assigning the class label to the given sequence data, chatbot, which is like the question and answer chatbot. So these are all some of the applications of these large language models. So now that you have understood about what is this large language models and its relationship, transformer architecture, its application, the next question that comes to our mind is how is it actually trained? So here, when we talk about training of these large language models, so let me tell you guys, a little while I would say it's not so far earlier. Okay, so uh, like what we had a major challenge, especially while working with these especially while working with these natural language data, was the limited amount of data that we had. So because of the limited amount of data that we had, and in order to train the large language models, we were actually requiring the large volumes of label data. Because of such challenge, we were unable to progress further in this NLP domain. Now, with the research paper of attention is all you need, and followed by other researchers at OpenAI and FastAI, like with all these team, so what we were able to observe is that if we make use of such large language models and perform the training using the unsupervised learning technique. Now, when we talk about this unsupervised learning technique, it's basically use the features without the labels. So what they have came up is we will make use of the large corpus of text data, and using this large corpus of text data, we would go ahead and perform the unsupervised learning. Now here, the task that we will do is we will perform the task of language modeling task. So what is language modeling task? As I've mentioned earlier, it's basically given a current word, what is my next word? So that's the overall idea right here. Okay. So here, uh, like we have started to perform this language modeling task, and obviously this doesn't require the label data set. Now, when that's a scenario, so since the requirement was without labeling, so we were able to perform this unsupervised learning training operation on these data set. Okay, so these training has been done on large data set on these models for the language modeling task, and whatever the output that I would get, let's say this is my trained model. Now this is the final trained model that we have got, which has been trained on the unsupervised learning manner for the task of language modeling. Now when we have this trained model, this trained model is not trained on any specific task. So we can use this trained model for multiple use cases. So we can call this trained model as something called as a foundational models or foundation models. So we call this model as a foundation model. So the ability of such foundation model to generate the text for a wide variety of purpose without much of the special instruction or training is actually called as zero shot learning. So if you're someone who's preparing for the NVIDIA certification, it's very important that you need to remember about these types, or the people who is appearing for uh, jobs which are related to generative AI. So these various types of learning is very important. Now, when I talk about the zero shot learning, it's basically the ability of the model to generate the text, like the ability of this foundation model to generate that text without much instruction or training or a special training. That's called as a zero shot learning. And apart from these, there are other kinds of learning as well. We have got one shot learning, we have got few shot learning, and so on. So these are all some of the variants of this zero shot learning, wherein the foundational model is fed one or few examples which will illustrate how a specific task needs to be completed, so that the foundational model can understand what exactly it has to do. Okay. Now, when we are having such a great, uh, like I will say, great ability with this zero shot learning, so you might think that you can use it in your application, or you can use it in your enterprise level, so that you can use it for providing the answers. But the problem is, okay, this model that we have got, that is a foundation model that we have got, it has been trained on general data set. Now, if you want to solve your own business problem, it is not at all been exposed to such data set. So if you want to prepare the model so that it is suitable for your application, then what you have to do is you have to perform the activity that's called as a fine tuning. So that is a core idea over here when we are working with this large language models, guys. So to deploy these large language models for the specific use cases, so you can actually make use of this fine tuning technique. Now, apart from that, we can also make use of other techniques such as prompt tuning and the adapters technique. Now, when we talk about large language model, so as I mentioned, it belongs to the class of the uh, the transformer architecture, right? Now, when we think about the various classes of these large language models, so this would include the encoder only models. We have something called as encoder only models. We have decoder only models, and we have the encoder decoder models. So encoder only models are basically the type of models which are suited for the task that can understand the language, and which would help us to generally perform the task like the classification. Now, the examples for the encoder only model is the BERT, that is bidirectional encoder representations from transformers. That's an example of encoder only models. And we have the decoder only models. This is the class of model, and these models are extremely powerful, and they are actually good at generation of the language as well as the content. So the use cases would include the story writing, question answering, blog generation, and so on. To give you an example of decoder only model, the GPT model, that is generative pre-trained transformer models, so it belongs to the decoder only family. And we also have the encoder decoder models. So in the case of this encoder decoder only models, so these models combine the encoder as well as the decoder components of our transformer architecture. Now, by doing this, we'll be able to understand and generate the content. And the some of the use cases of this architecture is the translation as well as the summarization. And to give you an example, like we have got an architecture which is based on encoder decoder, that is T5, which is text to text transformers. That's an example of the encoder decoder architecture T. Okay. Now, uh, okay, like now that you have learned about it, now how do you get started, or what is the key idea of this working with this large language models? So in order to work with these large language models, so what we generally do is we will make use of the prompts to provide the input to our large language models. Now, before we proceed further, guys, I want to know from you. So, folks, what are the large language models that you have interacted with, or which you have started using it? So, can you tell me what are the large language models that you have used it, or which you are been using it? Okay, Darshan says he has worked on ChatGPT. Rakshita says ChatGPT. Ramya says okay, yeah, Gemini. Okay. How about others? What are the large language models that you have worked with? Okay, Sangeeta has worked with ChatGPT. Excellent. So that means so you are able to by looking at it. Okay, so you you have got some level of exposure when it comes to the large language models. Okay, that's what we could come to know. I could come to know from your responses. So to give you the reason that I've asked you, because just to analyze, okay, what's the level of understanding that you have got. Now let me do one thing. Let me just open up one of the generative models that we have got, which is basically a chat GPT. Now, if you consider the chat GPT that we have got, chat GPT is basically an application which uses the GPT model, and this GPT model is based on the decoder only architecture. Now here, when you want to interact with such decoder only models, okay, when you want to interact with such decoder only models, so what you generally do is you will start by providing an input. You will start by providing an input, and this input that you would provide is called as prompt. Okay, the input that you provide to your large language model is basically called as prompt. So here it says message chat GPT. Now let's suppose if I mention the message as I want to cheer up my friend who's having a rough day, and so on. Suppose if this is my text, okay, if this is my text, or if this is my input for the model, okay, this input is what we call it as prompt. So this prompt will be understood by the large language model. Here in this case, the model that is powering this chat is Chat GPT, which is, I think it's GPT 4.0 or 4.0, or the latest GPT that we have got. That is what it is supporting right here. So this like this model that you would see right here. Okay, so this text is called as a this text is called as a prompt, and using this prompt, okay, the large language model is processing the text and generating the output. So that is the overall idea of working with this the large language model such as ChatGPT. Now, one thing that you need to remember is whenever you provide any input for this large language model, it's called as prompt. So it will use that information as an input, and based on that, it will generate the output. Now, these prompts will be remembered in the database, but it is not necessarily mean that the system has learned everything that you have provided in the prompt for future use case. So whenever we are working with the large language model and when it is in the prediction mode, so it is basically getting the input and generating the response for us. It is not learning new things as and when it progresses. And that is one of the reason when you start interacting with the chatbot, and especially the chat GPT, and when you ask a question which is relatively new, which is greater than the cutoff date, then it would say that I don't know about the things that you are saying, because this is the timeline in which I have been trained on. That means even though the user might have provided that information with various prompts, it is not part of the model's training. Okay, so that's the key thing that you need to remember while you're working with the prompt. Now, that doesn't mean that, okay, the prompt has no importance. The prompt has got a very high importance. The reason because depending on our prompts, that means depending on the requirement that we specify through the text as prompts, we are going to generate the response. So that's the idea about the prompt and working with this large language models, guys. Okay, now when you want to use such large language models for your application, so let me give you some examples and illustration as how you can work with this large language models. See, one thing that you can do is you can enable uh, uh, the you can actually enable the API settings, and you can call the API from this chatbot, ChatGPT. Okay, so I'll show you. So in order to work with the chat GPT, okay, so what you need to do is you need to log into the platform.openai.com. Okay, let me log into my account and I'll show it to you. So once you go to the site of platform.openai.com, this is how your page of this OpenAI platform would look like. Now, in order to get started, so first thing that you need to have is, so obviously you need to have your payment account set up. So you can go to the settings right here, and over here, ensure you add your billing method and you have a balance in your account. Okay, minimum it would allow you to recharge for $5. So you have to recharge your account, and then you'll be able to call like interact with the chat GPT in a programmatical manner as well. Okay, you'll have to just recharge and you can get started whenever you're working. Okay, now apart from that, see, if you look at it, there are other capabilities that are provided by this OpenAI platform. So one is chat. So here you can actually choose the model of your choice and you can go ahead and provide your input as well as provide your additional system information. So based on the system information and your prompt, the GPT model is going to generate the response. So for each and every question, it would go ahead and generate the response. Okay. Then we have something called as assistants. Now, when we talk about the assistants, so here you can use this assistants to actually like work as a personal assistant. You can also attach the file so that the system can go ahead and generate the response based on the provided data. And the similar project has been done in one of the courses that I've got an opportunity to create with Manifold AI Learning. So the course that I'm talking about is LLM Ops Generative AI Masterclass. So you can actually check out this course where we have built the similar assistant using the using this assistance API, like assistance feature that we have got in ChatGPT, and we were able to build it. We have packaged it into an application, and we will be learning about the Kubernetes, applied the CI/CD pipeline using the GitHub Actions. So you have implemented everything in then hands-on manner. You can also check out the same. That's an interesting project that we have done in this course. Okay, so I'll share you the link for your reference, but yeah, that's the overall capability team. You can create your assistant and you can build the assistant and you can use this created assistant in your service so that you can call an input and generate the response. Okay, so that's the role of this assistants, and we have something called as completions. So like they're actually the old models. You can use it, like you can provide some input and it will actually perform the completion. And we have the assistants, whatever the assistants that you have created so far. So these are all the assistants that I've created for experimentation purpose. That's what I would see right here. And threads refers to the conversational threads. So each and every conversation that would happen between uh, the in this case a chat GPT with the user, it is considered as a thread. Okay, so when the conversation is happening, you'll be able to track such thread and you'll get to know what is the input from the user, what is the response from the model, how the model is generating the response, and so on. And we have another ability that's called as fine tuning. Now here, this would allow us to fine tune the model using our custom data. And we have other features like the batches. You can create a batch, and you can, and here this actually talks about the storage is where you can get to see about the like you can actually get to see about the various files that I have attached, and usage describes the overall usage of your account and the API keys. You can generate the API keys from this page. Okay, so that's the overall idea about the large language models and working with the large language models, and then example can be an OpenAI. Okay, so folks, this was about what we had planned for today's agenda about uncovering the large language models, its abilities, and basic idea of working with this large language model. So if you have got any questions on any of the topics that we have discussed today, please feel free to let me know. And team, thank you so much, everyone, again for joining in for this learning session. And if you have got any question, please feel free to let me know. And all the today's session recording, as well as the previous session recording, is available in this link, that is Manifold AI Learning Workshop. Ensure you check out the page of Manifold AI Learning, register yourself so that you can gain the access to the course at Manifold AI Learning. Okay, and you can also check out the other products if something of interest to you. Okay, thank you so much again for joining in, and thank you for asking some of the amazing questions. So if you have got any question, please feel free to let me know. I'll be here for 2 more minutes, and then we'll be closing the session, guys. Okay, so there's a question about Azure OpenAI. Is it same? Okay, let me tell you. So I can say that Azure AI and OpenAI, they are actually closely related uh, like because obviously they're using a similar base model, but there are some key differences. See, if you think about the OpenAI, so it's basically kind of a research organization that develops and maintains the underlying large language models like GPT-3, GPT-4, and so on. Now, when we talk about the Azure OpenAI, it's a Microsoft Azure cloud service. Now, this provides the access to the OpenAI's model, but with additional benefits. And when we talk about the Azure OpenAI, it's more to do with the enterprise focus. Like it is actually created for scale in mind, so that it will provide the enhanced security, private networking, role-based access control, compliance certificates. So those are all the additional information that we have got, especially in the Azure OpenAI. But when we talk about the OpenAI, it's more to do with the community, like overall pushing the boundaries of the AI. So that's the core difference that I can say when we compare the Azure OpenAI and the OpenAI in general. Okay, and Blessy says, thank you so much. It was useful for development perspective. Which course should I take for AWS ML development? Okay, so if you're someone who's looking for machine learning in AWS, maybe I would recommend you to check out the course of MLOps with AWS, where you will be learning to master the machine learning operations with AWS. So this is what I would recommend, Blessy. Okay, any other questions, team? Okay, thanks a lot, everyone, for taking your time and joining in. So I hope to see you on our next webinar session. Okay, anything? Okay, sorry. I missed the last question. Anything specific to SageMaker? That's correct, Lissy. So here you have the section that is dedicated to feature store in AWS and how to work with this feature store, and how to perform the feature engineering in SageMaker, training and deploying the model with the SageMaker, how to create the custom model, so working with the SageMaker pipeline. So you'll be learning some of the practical concepts of performing the machine learning on AWS. So this course not only covers the development, that is the machine learning code implementation, but also looks into the other aspects about deployment as well. So that's a special thing about this course, that is MLOps with AWS. Okay, no problem, Lissy. Okay, any other questions, team? Okay, thank you so much again, everyone. And I look forward to seeing you on the next session. Take care.